add together 3-digit numbers. That might not seem like the best brag, but 10 years ago, it was. When I was 7 years old, I could walk up to a random adult and tell them that I knew that 102 plus 112 was 214, and they would look at me like I was a genius. It felt amazing. It's not like I was born with this ability. I was strongly encouraged by my parents to fill out dull, repetitive worksheets until I memorized the algorithms to solve certain types of problems. Because I encountered so much math outside of school, the problems I saw in school were ones that I already knew how to solve, making it seem as though I was just naturally talented at math. By 7th grade, I could graph a line and multiply negative numbers, and I knew decidedly that I was a math kid. I was put into an advanced group at school, and we were given a packet to solve. I spent hours on this packet every night, determined to find the answers. I turned in my completed packet, feeling proud and confident. There were 20 questions on that packet, and I got 12 of them right. I could have felt proud of myself for answering 12 questions correctly on a really challenging packet, but you see, I was a math kid. And that meant that anytime I saw a math question, I was supposed to look at it and just know the answer instinctively. 12 out of 20, 60%, that felt like failure. I took that graded packet out of my bag and hid it in a stack of papers, hoping I would never see it again. That was the first time I saw problems I had no idea how to solve, but it certainly wouldn't be the last. All of a sudden, it wasn't enough to just memorize an algorithm or repeat a formula. I had known for a while that to find the equation of a line, I could use the formula y equals mx plus b. But for the first time, I was asked to prove it. Figuring things out on my own was messy, time-consuming, and honestly really hard. But it was also so exciting and rewarding. What I've noticed about people who really love math is that the problems that excite them are the ones where they barely have any idea where to start. These are the problems they spend hours on, trying over and over until they finally find something that works. And when they do, they're on top of the world. Solving a challenging math question is like completing the New York Times Saturday crossword or clearing out 4 rows in Tetris. You get this thrill from putting in effort and reaching a satisfying conclusion. Proving a theorem, it's like reaching into a mirror and shaking your own hand. There's magic in taking something abstract and distant and turning it into something that feels real. The math questions that excite me to this day are the ones I have no idea how to solve. My favorite moments in my math classes are the ones where we're trying to prove a theorem or figuring out why something works. At the end of 7th grade, my family moved, and while I was packing, I found that math packet. This time, without the pressure of grades or the expectations of other people, I decided to reattempt those problems. This time, a failed attempt or wrong answer didn't mean that it was time to give up. It just meant that I was one step closer to the solution. The most important skills that math has given me are problem solving and perseverance. Skills like breaking down a large problem into smaller chunks, looking for knowns and unknowns, finding patterns, or approaching things from a new perspective are useful for more than just math. Whether it's trying to figure out if that deal at Costco is worth it or tackling global issues, the skills to approach an unfamiliar problem are really, really useful. Math gives us the problem-solving and perseverance skills to tackle the unknown. Unfortunately, these problem-solving skills are missing from a lot of our math classes. Imagine for a second that I told you that tomorrow I was going to give you a test. And on this test, you would have a bunch of right triangles like this one, and I want you to find the length of the missing sides. Now, you could go home and spend a couple of hours playing with these triangles and trying to see if there's a relationship between these sides and trying to prove when it works and why. Or you could find a nice formula like this one, a squared plus b squared equals c squared, practice plugging in the numbers to get your answer, and go into the test feeling confident that you're going to know how to answer every question. Our ways of measuring math knowledge, everything from quizzes to standardized tests, rely on students taking a problem they've already seen and reusing the steps to solve a similar one. Doing well in math class means memorizing formulas and algorithms, and that can sometimes mean that students lose sight of problem solving. I'm not going to pretend that I know how to reform our math education. Our world is built around this idea that being good at math means being able to quickly solve a wide variety of problems. It's so hard to do this and also find the time to teach problem-solving things and also talk about why everything works. But I do think that there's a problem. I think we've become so focused on solving for X that we've forgotten to ask why. When we talk about the reasons we teach math, we say that it's because math is interesting and useful. In my experience, math became infinitely more interesting when it was about the things I had no idea how to answer. And math became infinitely more useful when it gave me the problem-solving skills and perseverance to tackle the unknown. There's more to math than memorization. The kind of math that's interesting, that stretches your thinking, that feels rewarding, the kind of math worth doing is the kind you're seeing for the first time.